So I'm going to get started. My name is Professor Girija Ranade, and I'm one of the faculty members here in the EECS department at Berkeley. I teach a variety of different classes, and one of the classes that I teach might be a class that you'll be taking here in the fall if you come, and this is called the class EECS 16A. And this class is designed to really introduce you to the department as a whole. And what I want to do today is talk a little bit about this class, as well as try to give you a sense of what this EECS department is really about and show you the different kinds of offerings in terms of coursework that you can take if you end up being a student here at Berkeley. So congratulations on getting in. And what I wanted to do was, I guess, as I said, talk a little bit about the different offerings that we have here. And the way I wanted to do that was to start with a little bit of a Q&A so that we can all see where we're at. So feel free to unmute your mics and chime in, reply yes, or feel free to shout out the answer. This is Zoom, so I wish I could make it more interactive. I would do this in an actual classroom, but I don't have the chance here. So if you feel comfortable, unmute your mic and feel free to shout out the answers. So how many people have heard of Shazam? And how many people have, used a GPS on their phone? Presumably a lot of people. Yes? Okay, people are voting. So lots of people are voting. That's great. Do you know how these things work? And did you know that the idea, the core idea that is used in Shazam is the same as the core idea that is used in making the GPS on your phone work? Anyone have any ideas what this concept is? This is a core concept in computer science and electrical engineering, and you'll learn about it your first year here. Any guesses?
Databases.
Sorry, I didn't hear that.
I just said databases.
Oh, well, databases, I guess, are used to some extent. You're right. This is a core technology that is used in the background of both. What I wanted to get at was an idea called cross-correlation, which is a key idea that is used in all kinds of signal processing and all kinds of machine learning. And it tells you, it helps you identify when two signals are similar to each other. And so, things that are as different as Shazam and GPS both use this exact same idea. And you'll learn about it your first year here. What about the idea that, let's say, allows the touch screen on your tablet to work? This is the same idea that allows an autonomous car to drive in a straight line. It's the same set of ideas that actually allows the PageRank algorithm that led to the revolution of the search engine space. That's the same idea driving that. And it's the same idea that allows us to, really train deep learning neural networks, for those of you who might have heard of these things. Any suggestions, any guesses on what that might be? I guess you can also type into the chat if you feel like doing that. For everyone who hasn't seen the chat, this is where the chat window is. Should pop up on your screen. Well, no worries if you don't know about this, because you will learn this the first year here, you're at Berkeley. And these key ideas are feedback, eigenvalues, and stability. And these are, again, key concepts that feed into this big buzzword of machine learning that you might have heard about. Machine learning is this big catch-all phrase. These are specific mathematical concepts that we will teach you that will help you build each one of the ideas that are mentioned on this slide. What about a fundamental algorithm in machine learning and AI that is used basically every single time you see someone making a prediction on something? Probably they're using this algorithm. It's used to make predictions in biology, brain-machine interfaces, in social sciences, imaging algorithms, and much, much more. Optimization, yes, optimization is absolutely used. And what we will learn about is one specific algorithm in optimization, and this is called least squares, which is the fundamental algorithm in optimization. And as you will take the courses throughout your curriculum at Berkeley, you will learn this your first semester at Berkeley and keep building on this very idea throughout your senior year. So these are all different ideas that are enabled and play key roles in the understanding of electrical engineering and computer sciences, and make up this very, very diverse and broad department that we have here at Berkeley. So a last one. Name an idea that allows Netflix to give you recommendations for movies. It helps you uncover voting patterns for politicians. It helps you figure out genetic trees. And it can help you to build better cameras. This one is going to be pretty tough. I don't know that people will know this, but by the end of your first year, you will learn this. And this idea is called singular value decomposition. It shows up, it's related to clustering, it is related to data mining, but the underlying mathematics that makes it possible is actually based on understanding how these mathematical quantities called matrices interact with each other and how they interact with vectors. So this is the foundation that we will build for you in your very first year here at Berkeley. So when you come to Berkeley, there's a series of introductory courses that you can take. And these courses are known by their course numbers, as you will soon find out when you come here. So there are two classes at Berkeley that are intended for people who have had very little prior exposure to programming. And these two courses are Data 8, which really introduces you to basic programming and data processing, as well as CS10. These are introductory data science and introductory computer science classes. And a lot of students who have not necessarily taken a lot of computer science before choose to take these classes. After this, there's a series of 6 key lower division courses in the department that really form the heart of what this department is about. One of the things that makes me love Berkeley is how powerful our lower division courses are and the strength of student that they produce at the end. We really try to teach you everything that we think is important. I think these 6 courses are really the gemstones of the Berkeley Computer Science and Engineering program. So there are these 3 courses that are more on the computer science side and talk about programming fundamentally. So there's basically CS61A, which maybe many of you have heard of. It talks about programming, introduces this idea of computational thinking. From there, you can follow on to this course 61B, which talks about programming again, as well as data structures and how you can build more sophisticated software. And finally, this builds to 61C, which is the class that teaches you about machine structures and registers and how does the memory inside a computer actually work? How does computation actually work? And on the parallel side, there are 3 other courses that form the more mathematical core of the department. The first of these is EECS 16A, which talks about computational thinking, and it builds the foundations for machine learning and design. Here you'll learn a lot about linear algebra and some of the concepts that we just talked about. From there, you go on to EECS 16B, that again, builds further on these machine learning ideas. And finally, from here, you go on to what is the most mathematical course, which talks about how to really do a proof or different kinds of computation. It teaches you about induction, it teaches you about probability, and this class is what is CS70. So these are the 6 lower division classes. I'm not going to be able to go into detail on all of these courses today, but I'm going to try and give you a little bit more information about EECS 16A and 16B, and give you a flavor of what the upper division courses are that you can take from here on out. Okay. So what are EECS 16A and 16B? These are courses that are fairly new at Berkeley. They've only been around 5 years as compared to the introductory programming classes, which have been around for, decades. And what this course is trying to do is it's really trying to acknowledge the fact that we live in a data-driven era where being able to understand what data means and being able to process it is really fundamentally important. And what these classes try to do is they try to say, well, if I want to be a successful electrical engineer and a successful computer scientist, I need to be able to follow the full pipeline. I need to be able to take data from the real world, process it, collect it, model it, make a model, use that model to then make an inference about the world, and then go back and act on the world. And this is what is called a closed loop, in the sense that you start from the physical real world, you go to some software system that processes the data, and then you go back and make impact on the physical world. And these classes try to really train you to think like an end-to-end engineer. So you want to think about, modeling and problem formulation, which 16AB will talk about, and it'll also help you think about design thinking. And we want to do this while preparing you really in the fundamentals of AI and machine learning that are really important skills for engineers in this age. So we'll talk about how to model, design, and build systems, and we'll talk along the way about linear algebra, feedback, signals, systems, control, circuits, machine learning, so much more. The goal of this class is to really show you how integrated and how diverse this department is. Oops, how do I click? Yeah, so the first class that you will take, 16A, will have 3 modules. And these 3 modules are roughly, you can think about them as introduction to systems, introduction to design, and introduction to machine learning. So introduction to systems really talks about, well, what does it mean to be an engineer? What does it mean to be a system? What does it mean to design a system? And we'll talk in detail about how we might be able to design a tomography system. So what is tomography? It's basically an imaging system. So if you've ever heard about an MRI or a CT scan, these are examples of tomography. And here, what's happening is that you're using somehow some kind of physical device to get data from the real world. So for example, you might be imaging someone's brain. You're using that information, somehow processing it, and then making an inference about the medical state of that particular person. And we'll talk about how these systems are built and modeled. And in fact, in the lab, you will build a very small version of this. The next module will focus more on design, and it will help you, connect the dots. So this will, introduce you to what is the touchscreen lab, which is, one of the favorite labs of many of the students. And the last module is introduction to machine learning. 16B will then talk about, differential equations. It'll help you understand an introduction to robotics. And the final project in 16B really brings all of the ideas together, where you learn to use unsupervised machine learning to actually control a robotic car. And I'll show you a final video of this at the end. Okay, so let me show you a little bit of the introduction to the labs in 16A. I want to just, can people, no, people cannot see my screen. Give me just a second. Okay. Can you see my screen now?
Yes.
Yes.
Okay, yeah. Great. So 16A is a very intense and unique class in the sense that it's a math class where you build stuff using math. And so for every single math concept that you will learn, you will actually build something that uses that mathematical concept. So here I'm showing you a video from a lab that is being conducted in the second module, which is the touchscreen lab. And this basically shows you how the basic touchscreen on your cell phone works. So what you'll see is you see this green little pad here. This is your touch screen. And what you want to identify is which of these little points is being touched by the person. So if I click play, you'll see this. You see the screen, look at the GUI lighting up because it's identifying essentially which button was exactly pressed. So you can see the top right green button being pressed. And this is an example of what is called a resistive touchscreen. And we'll help build these out in the class. And the other thing I wanted to show was this video of a capacitive touchscreen. This is the other cool lab from the second module. Let's see. So notice every time the touchscreen touches, what you see is that you actually have this light going on and off based on detecting the touch. Okay. And you can see exactly how you can detect from this changing of these waveforms based on whether or not the device is being touched. Okay, let me go back to sharing this. Okay, the final video I want to show you is of the final project in 16B. So again, I am assuming you can see my screen. And let me show you this video.
And if you go straight. Fairly straight.
Okay, so what this student just did was they built a speech-recognized speech classifier and used 2 different voice commands to command the robot to do one of 2 different things, either go in a circle or go straight. And basically, this is basically pulling together this entire first-year curriculum that you will learn to build this exact robot completely from scratch by the end of your first year. So before we end up, I want to save some time at the end for some of our amazing TAs and students to talk. But I really wanted to address this conversation that I've seen happen a lot about in incoming students, is what is the culture at Berkeley like? And I really think that the amazing TAs that we have make a huge difference in the quality of education that we're able to provide. I think the TA culture is what makes Cal unique. And I think we're blessed to have an amazing student body that always inspires me every time I walk onto campus, who are so motivated to really think carefully about how they can improve the educational experience at Cal. And so even though we have a classroom that sometimes holds up to 1,000 students or even more, we really make an effort to have every student get to know at least one of the TAs. And I think you can hear from the students more about what this means for from their perspective. You'll hear from people who are currently on core staff, and they can share a little bit about their perspectives. And so I really want to let you know that even though we have really large class sizes, every single one of us here, every single person on the faculty, and every single person on the TA staff cares deeply about making Berkeley work for you. Not making Berkeley work for a generic arbitrary student, but making Berkeley work and making the little tweaks that make it so that we can personalize the educational experience to students as much as possible. We know that all of you are coming from different backgrounds. You're coming from different parts of the state, different parts of the country, different parts of the world. You all have different personalities, you have different interests. Some of you really want to, explore different industrial job ideas. Some of you really want to go to grad school. Some of you aren't sure what you're interested in. Some of you want to double major. Some of you are figuring things out. We understand this, and we really want to make this work for every single one of you. And the great thing about Cal is that I think that there's a place here for everyone. So with that, I'm going to close with a piece of general advice, which is that, you know, one thing that I see a lot of students coming in with is that they feel a lot of pressure coming to Cal. And I want to remind every single one of you that you don't have to fit into a box that someone else defined. You know, it's okay to be different. I encourage you to explore, find yourself, grow. Don't feel like you have to take certain courses because someone said that you should take those courses. Don't feel like you have to, you know, be a certain kind of person. This is your chance. Yes, college and high school can be very, very stressful, but remember to own it and enjoy the journey. You know, enjoy spending time here, enjoy meeting the people, enjoy taking the bizarre classes, enjoy learning about things that you never even knew existed. So with that, I'm going to really try to have some of our amazing TAs and students share their experiences with you so you can hear from people who remember more closely what it's like to be an incoming student. So are the TAs online here? And Anika, do you want to go first? I'm going to stop sharing and have you unmute so that you will be visible to everyone.
Okay, hopefully everyone can hear me okay. Hi everyone, my name is Anika. I took this class my first semester. I took EECS 16A my first semester here at Berkeley. I'm currently finishing up my sophomore year and I've been on course staff for 3 semesters now. And my current role is as a discussion TA. So we'll talk about this a little bit, but I just definitely want to give a little bit about my perspective. What was it like for me coming into this huge school, and how did that go? So one of my concerns, which I bet many of you share right now, is it feels kind of scary that we're told that there's these huge class sizes, but I want to assure you that it's much, much better than it sounds. So the large class sizes can be worrisome, but because there's so much support from a whole bunch of core staff just focused on giving you that more personalized experience, you really have an ability to feel like you're learning in smaller settings as well. And so we have these things called discussion sections, and then we also have the labs that we saw some amazing videos of, which are smaller settings of much fewer students, and you have an ability to work through problems and cover the concepts again from lecture. You have a chance of getting hands-on in the labs and actually applying these real-world concepts of what you're learning in lecture. So it's not just theoretical, you're seeing how could this be used in the real world, and you're getting a chance to actually hands-on and do that. And so those are super interesting, and it really helps you feel like you're getting outside of simply just the classroom setting, and learning a lot more. And then I just want to say that, you know, when I was taking this class, the core staff was absolutely incredible. They really care and they're super enthusiastic, and they want you to succeed. So if I had any concern, I could always go talk to them, and they would have the answers for me. And so, you know, that's kind of what encouraged me to end up joining staff and, you know, give back to that great experience. But I really hope all of you do decide to come to Berkeley and take this class, because it is a really great experience for you to get an introduction into electrical engineering and computer science, and, you know, and start seeing how you can really make a difference in the world. Yeah, I'm going to pass it on to another TA.
Thanks, Anika. Grace, do you want to go next?
Yeah, okay, hopefully you guys can all hear me. I'm Grace, I'm a 4th year EECS major. I took 16A my freshman fall semester, first semester coming to Berkeley. And yeah, here I am. Basically, I took it right when I got to Berkeley. I really loved the class. I loved the content. I loved how hands-on the labs were. And I was actually able to meet a lot of friends through just doing homework for this class and studying together. So it was a huge part of my experience as a freshman at Berkeley, and I really, really enjoyed it. I enjoyed it so much that I decided to start helping out in labs as a lab ASC and eventually became a teaching assistant. So as a TA at Berkeley, you are super involved in the courses you teach. You do everything from creating course content to holding office hours to leading your own lab or discussion sections, and you're definitely super involved with the students. I was also an administrative TA, and this is a really cool role where I actually got to work really closely with the professors in setting course policies and handling student concerns. So I really enjoyed that part. And I think the Berkeley EECS department, part of what makes it so awesome is that you have all these undergraduate TAs, both number one, it's a great experience to teach and you really get to give back. But also as a student, I found it really helpful that a lot of my TAs were people who have taken the exact same classes recently, who are also Berkeley students, and who really understood the experience of being a student here. And I think that definitely makes the classes a lot better. Yeah, and after I graduate, I'm planning to go to grad school. I'm studying robotics and AI. So a lot of what Professor Ranade said about these intro courses are things that I'm still using today. Okay, cool.
Great. Ryan, do you want to go?
Yeah, sure. So yeah, I actually just graduated last fall, 2019, as a EECS and engineering physics major. So you don't have to just be EECS to take this class. And I'll be starting grad school at Davis in the fall in embedded systems, which actually was like I chose that field partially because of my experience working or just taking 16A and working with the class for so long. So yeah, I took 16A back when I was a sophomore in 2016. And when I took it, I actually didn't enjoy the class as much as I enjoyed the content. I really liked the content. I loved the labs. I think building things is like generally awesome. So I really actually enjoyed that aspect of the class. And so I ended up joining course staff because I wanted more people to see just like, yeah, basically that awesome side of the class. So yeah, I spent 4 semesters helping in the on the like in the labs in the class. Ended up as a lab TA, and then after that I was 2 semesters as a discussion TA because I also really like teaching. So the labs I think are really awesome just because like personally I like building things and I got to build all these like really cool things that you can't normally do with just like Legos and stuff. So like building things like a camera with a single sensor, touchscreens from basically scratch. And there's also like a lot of I know cool things that are in the works that some of the other TAs like are working on getting up and running. Things like audio-based data transmissions. That's like it's all these really cool things that like you never would have thought possible are like made possible just with like a first year like undergrad like lower division course. So I really yeah thought it was pretty awesome. And it's not just an EE thing. I think that's a common misconception, but it's like definitely like a lot of the stuff we do in lab is totally related to both things. So if you're thinking like that you're probably going to be more interested in CS, don't let that like discourage you from taking this 16B, because it's definitely like completely relevant. So yeah, that's what I got.
Great. Akash?
Yeah, can people hear me? Okay, great. So hey everyone, I'm a third year EECS major. I'm Akash. Congrats on getting into Cal. So I'm a EE16B discussion TA, so that's the second course you'll take after 16A. So I took 16A and B as a freshman my first and second semester, and they were a couple of my favorite classes to this day. And the reason why I really loved them is because, you know, when I came out of high school, I had a little bit of programming experience and I thought I knew what CS and EECS was all about, but those classes really taught me the reality of the situation, which is that CS is not just programming and E is just not just circuits. There's so much more to both of those fields, and they're very interrelated. So the way I think about EE16A and B as a student and now as a TA is that it kind of offers you as a student a pretty in-depth introduction to almost every major subfield of EECS, whether it be circuits, robotics, math in like linear algebra, machine learning. It lets you explore these things and get hands-on with them with the labs, as other TAs and professors and Professor Ranade have mentioned. And it lets you A, choose what kind of upper divs you want to take, B, it lets you choose what kind of activities you want to pursue throughout your kind of career at Cal. So that's what I found to be true as a student and now as a TA. And I think that it's a very important class to take and you learn a lot. And a quick note is that as a student coming into Berkeley as a freshman, I was super confused because of all this different advice I got, but I was super glad I stuck with the recommended 16A, 16B, along with 61A, 61B path because I learned a lot and got to apply it throughout my experiences so far. So super excited.
Great, thank you, Akash. Michelle, do you want to briefly introduce yourself?
Yeah, for sure. Hi, I'm Michelle. I'm a third-year EECS major. I TA'd for 16A last fall, and I took 16A in my first semester. I came into college without prior knowledge of linear algebra or circuits, which is the two main subjects of 16A. So I wouldn't have been able to answer the questions that Professor Ranade asked in the beginning. And I think the course does a really good job of acknowledging that people come from a variety of backgrounds, as the professor already acknowledged. And in my experience as a TA, 16A tried really hard to make sure every student who wanted to succeed could do so, regardless of their background. Oh, Professor, you're muted.
Yeah, you muted yourself, Professor.
What I want to do for the next few minutes is I want to just give you a brief introduction to what upper division classes that you will have access to after the 6 lower division courses that you have at Berkeley. And after that, I want to just have a little bit of time left to answer questions. I know that there are people who have specific questions about, the possibility of doing labs online and so on and so forth. But let me just give you a brief introduction and I'll get back to that. Okay, so can people see my screen again? Yeah, okay.
Yeah.
So 16AB basically gives you an introduction to the entire department. We will talk a lot in detail about 2 technical concepts that build on basically, or giving you the foundations of linear algebra on one side, as well as design and circuits on the other side. And these pull together to talk really about learning, control, systems, signal processing, so on and so forth. And from here, you can go on to courses that are on the mathematical side of the department, such as Introduction to Probability, as well as courses that are on the more physical side of the department, such as Introduction to, how does the memory in a computer work, or how would you actually build a Fitbit? So these are kind of 2 different paths that you can take in our department. And along each of these paths, there's a lot of different courses that you can take, and there can even be a lot of courses that are exactly in the middle or in the intersection. So on these red circles on this side, you have courses like optimization, AI, machine learning. And I hear from students a lot that they say, well, yeah, you tell me this is a course on machine learning or optimization, but I don't know what optimization means, right? What does that mean in the technical sense? And don't worry that you don't know what that means just yet, because we will talk about this in your first year course. So we'll help you figure out which courses you want to take. We'll help you figure out if you really care about this modeling and mathematical side of the department, or if you really care about the physical side of the department where you get to build things. So for example, there are classes that teach you how to build a solar cell. There are classes that teach you how to build the actual chips that run the high-powered computing that is so useful, that is so widely used. There are classes that teach you how to build large-scale software systems that are focusing on security, that are focusing on how compilers work. And there's classes like these yellow bubbles right in the middle, which are really bringing together both the physical side and the mathematical and software side of the department, such as robotics, such as thinking about control, such as thinking about, again, embedded systems that, for example, Ryan is going to study, but is a word that most freshmen don't know the meaning of. And you will figure all of this out by the time you come here. But what I want to emphasize is that we have a very wide range of course offerings. And what this means is that there's many different ways in which you can graduate with an electrical engineering and computer science degree from Berkeley. We don't tend to produce one standard, template of a student. We tend to produce many, many different types of students. And what we want for our students is we want you to become the best version of you. We want to take your strengths and amplify them. We want to take your interests and broaden them. And we want to take your weaknesses and help you build tools to eliminate them as much as possible. So because we have so many different types of courses, we think that there's a place in this department for every single person, regardless of exactly what your interests are, exactly what your background is, exactly which high school you went to, exactly which AP courses you were or were not able to take in high school. All of that is not going to really matter once you come to Berkeley, because we will find ways for you to carve out paths that work for you and for you to take ownership of the rest of this journey. So with that, I think I will stop. We've already had the student and TA perspectives. There's a couple of FAQs, but actually I think I'll just pause on this slide. And I want to use the rest of the little bit of the time that we have left to try and answer some of the student questions. So let me go back to the chat window. And let's see. So I've heard a question basically around concerning the labs and concerning what will happen to the labs if, we don't know yet whether what's going to happen with the shelter-in-place orders come the fall, or we know that some students might not physically be able to come to Berkeley. And we're trying to figure out ways in which we can offer these courses online. In fact, we will be offering 16A and 16B online over the summer. And we've been doing a lot of work to try and make the lab experience work remotely. So by having a couple of simple components at home and interacting with TAs over Zoom, we're going to try and recreate as much of the physical lab experience as we can for you remotely. And we're going to do our best, and everyone's been working really hard behind the scenes to make sure that we don't, that you don't lose out on this educational opportunity. So that was one question that I definitely wanted to address. So there's some basic questions that I'm seeing here. There will be a recording of this posted, and it will be available later for everyone to see. I'm not entirely sure where it will be posted, but I believe it will be posted to the Cal Week website, and it will also be posted to the EECS event agenda. So you should be able to look at it there. Do students take 16B and CS70 at the same time freshman year? So let me give you a typical breakdown of how students take courses and what we recommend. What we recommend is that students come in and, if you have taken calculus already, then we recommend you start with taking 61A and 16A in your freshman year, 61B and 16B in your spring semester of your freshman year. So typically 16A and 16B are taken before you take CS70 because these courses are designed to provide the mathematical background that help people succeed in CS70. So we recommend you take these first, and then The third set of courses that people typically take is 61C and CS70. So hopefully that answers that question. Is it all right to take 16B while taking 70, or is it recommended to take it after? We strongly recommend taking 16B before taking CS70. It will help you do better in CS70, and the concepts in 16B are more simplified compared to the concepts that are taught in 70. What do you recommend regarding freshmen taking 16A or 61A online over the summer? I think if you're coming to Berkeley and are thinking about, getting an early start, you are welcome to try to take one of these classes online over the summer. I definitely do not recommend trying to take both. I think that's, it's just too much work. One of the things that I always notice students coming into Berkeley are shocked by is the pace at which Berkeley courses tend to go, and college courses in general, as well as the rigor at which they are taught, is very, very different compared to what students see in both institutions like high schools as well as community colleges. So please don't overload yourself, and take courses at a reasonable pace. When and how do we begin choosing classes? I believe that there will be a link sent out to everyone for this, but maybe one of the TAs can answer this question. How and when do we begin choosing classes?
So I can maybe answer this. So how enrollment works in general is that once you sub, you'll have this portal called Cal Central, in which you'll have your admissions times exactly written on there. So you'll have a tab called Academics. And on there, each person is given some specific enrollment times. And so in Berkeley, it's a little different than what you might be used to, where we have a couple different phases of enrollment. So we have something called phase 1, something called phase 2, and then we have an adjustment period. And so during each of these periods, you have a certain amount of units you're allowed to enroll up to. And you'll be given the date at which each of your enrollment times start on this portal. And so I highly recommend just looking there, and it'll give you a lot more information about where you can go to. So we have another site to figure out which classes are available. There's another feature to help you with scheduling, but ultimately there it's going to tell you how to enroll and when you can enroll.
Thank you, Anika. I am also seeing a question about the workload, and one of the things I wanted to address was, again, Berkeley classes. No class at Berkeley is easy. Basically, it is true that every class at Berkeley is a lot of work, but the reason we do this, and the reason that we think that this is a valuable perspective, is that we want to train you at Berkeley in a protected, controlled, safe environment to allow you to, grow as much as you can, so that you can be prepared for when you start your first job or when you go to grad school, that you will be super prepared with the tools to work hard and the concepts, so that no matter what comes after, it's going to be easy. So for students, for the workload, they typically experience the workload their freshman year as significantly harder than what they saw in the previous institution that they were coming from. So we want all of you to be prepared for that. We recommend students don't overload. And if you try to stick to taking 2 technical courses every semester, you should be okay. And this number varies by student, right? For some students, the right number of technical courses to take is 1 technical course. For some, it's 2. It's something that you really have to try and figure out on your own. And one of the things that we really emphasize is that it's not the same number for everyone. Every student is different. Berkeley is a giant place. So it's really hard to say what the typical workload is like, but make sure that you pace yourself and don't, if you're feeling overwhelmed, make sure you drop classes. And there's lots of resources to allow you to, have a course load that you can actually manage. Other questions? How do we know which classes to enroll in fall semester? So the EECS website has sample course plans that we really recommend that you look at, that will tell you, depending on what courses you've taken before coming to Berkeley, how and where you can start with in terms of taking these courses. So we recommend, again, for the fall, if you're intending to major in CS or you're in the EECS program, we recommend you take 16A and 61A if you've taken a calculus class. If you haven't taken a calculus class, then we recommend your first semester you get that calculus class done and then move on to 16A, 61A the following semester. Is grade deflation common in EECS classes? So let me tell you a little bit about how grading works at Berkeley. For all of the lower division classes, what we do is we know that we have a large volume of very, very talented students. And the way we grade is we say, look, we're going to set a certain expectation of what it means to have an A, a B, or a C in a class. And based on that, we, just grade students based on that set threshold. So there is not a curve in the class in the sense that you will not be competing against students. There is no notion that a certain number of students, only a certain number of students can get an A, or a certain number of students must fail the class. This is not how the classes operate. So for a class like 16A, you will be told in advance how well you need to do to be able to get a certain grade, and you'll be able to go from that. That said, grades matter far less in a college environment than they have in your previous institutions, most likely. So the experience and what we emphasize is really trying to learn the concepts. What I've seen happen many times is that students don't do as well in their first course freshman year. And then, once they've learned the kind of how college works and once they've gotten settled in, they really take off. So try not to worry too much about grades in general. That's the piece of advice that I have on that note. What is the difference between L&S CS and EECS? That is a great question. From the perspective of your degree, the answer is there is none. You take almost exactly the same set of courses. And when I talk to a student, I almost never know which program they're in. In fact, I have known every single TA here for multiple years and have had multiple long conversations with them. But the details of their major has never been a topic of our conversation. So majors are they're just a label. In fact, I'll ask you, how many people do you think ever asked me what my major was? Basically, no one. For that matter, how many people do you think asked me what my GPA in college was? Again, no one. It doesn't really matter. The only thing that is different between the two courses is that the entry paths are slightly different. And if you want to declare CS through the College of Letters and Science, then you will need to meet the GPA threshold. And for this, you will have to take 61A, 61B, and 70, and the average GPA in these classes is what will count. Again, for students in both tracks, our recommended courses are exactly the same. 16A, 61A first semester, 16B, 61B second semester, and 61C and 70 in your third semester, so that you can use 16A and 16B to help prepare for 70 and maximize your grade there. Other questions? What am I looking through the chat? There's a question on how accessible are the adjunct lectures for EECS core classes, but I'm not sure I understand what that question means. So whoever asked that question, if you can just clarify that, that would be very helpful. Oh, what opportunities does the EECS program offer in terms of clubs, research, and internships? I think this is one of the really amazing strengths of our program. We have a huge faculty, and as a result, there's a great variety of opportunities that are available. One of the other exciting things, and one of the things that really motivates me to be here, is the creativity and drive of the student body. And what this means is that students create clubs and even teach courses that allow you to engage with a wide variety of ideas that that can be quite powerful. We do encourage students to try and do research, and a large number of people end up actually getting involved in something outside of their coursework. So students are either get heavily involved in some kind of club, or some of them choose to TA, or another group chooses to try and do research. These are things that you can explore once you come here. One of the nice things about being at Berkeley is that you will have PhD students teaching your discussion sections. And what that means is that you can go and talk to them about their research. And often they're looking for undergraduates to help them out, run an experiment or write a piece of code or do a calculation. And a lot of the people I've seen successfully go on to grad school started research this way, by talking to a graduate student and learning about what they were doing. So there's multiple opportunities to talk to teachers in your discussion sections and actually get your feet wet in terms of research. Okay, a question: is EECS essentially a double major between computer science and electrical engineering, or is it more focused on where the two intersect? That's a great question. And I really think that these labels are something that are sometimes very, very challenging to understand and often more confusing than needed. And this is true not just in terms of the EECS department, but I think this is a concept that is true just in life. Labels are unnecessary, and we often tend to emphasize them more than they are needed. But when we think about electrical engineering and computer science in general, fundamentally, the reason that we have a joint department is that these ideas are so intertwined that it is hard to identify whether something is engineering or whether it's computer science, because these concepts grow in and out of each other. And it is possible to take, many, many, many different paths through this major. You don't have to take a path that's just along. You can take a path that exposes you to ideas on the hardware and the software side. You can take a path that exposes you strictly to the hardware side, strictly to the software side, strictly to the mathematical side. But it's really hard for me to fully answer that question because everything is connected. And sometimes by artificially applying labels such as, oh, are you in the College of Letters and Science or in the College of Engineering? These labels are entirely artificial in terms of the content of what you're learning. The courses that you're required to take, no matter what label your degree has, are exactly the same. So just don't think about these two things as different, really. A friend is trying to take, okay, I'm not sure about the transfer question. A friend is trying to take 16A while being a transfer. I'm not sure about this question. Maybe message me privately and I'll try to answer that question privately. I'm not sure I understand this question in detail. Do you guys recommend joining programs like Prep, EECS Honors, ES2, etc.? I think you can join them or you cannot join them. I think I've seen students succeed through joining programs. I've seen students succeed through not joining the programs. There's no generic answer that I can give for all students. For some students, the answer is a resounding yes. For some students, it might not matter. For some students, it might be better not to join them. It depends on the specific program and on the specific student. That's why we have so many different programs, because we hope that you can find the program that is right for you. So a program that might be right for you might not be the right program for your friend. So that's my advice in terms of specific programs that you have. What else? Do you recommend students take? How do we know which classes to enroll in for our first fall semester? If you're intending to be, if you're in the EECS program, then I strongly recommend that you take 16A and 61A your first semester, assuming that you've had calculus before. If you are in the EECS program but you have not had calculus before, then first take a calculus class and then take 16A and 61A the following semester. That's what I recommend. If you're in the L&S program and are intending to declare CS, the answer is exactly the same. If you have taken a calculus class before, take 61A and 16A your first semester. If you have not taken a calculus class, first take the calculus class, then take 16A, 61A. When do most L&S CS students declare their major? Again, here there's a really wide range. I don't think that there's even an answer. I was actually trying to get some data on this recently, and it's actually hard because people declare at all different times. Berkeley is a big place and everyone is different. And so what I really want to emphasize again is that please, as much as possible, I know it's really hard it's much harder to do than for me to say, but build your own road through Berkeley. Just because someone else that you know, maybe from your high school or from your community, did a certain thing at Berkeley doesn't mean you have to do that. Just because some upperclassman you talked to during Cal Week said you should do something doesn't mean you have to do that. So some people will declare their major in their sophomore year. Some people will declare their major in their senior year. Both groups of people can be successful graduates from Cal. They will be different, and that is good. So don't worry about when you're going to declare. It'll happen when it happens. A natural sequence of courses to take is, again, I said 16A, 61A, 16B, 61B, and then 61C and 70. And by that path, typically you will declare then your sophomore year. Other questions? Yeah, any last questions that I haven't yet addressed that you think you would like to have me address? So if we want to take CS10, should we take CS61A in the spring and not fall? And the similarity of CS10 to AP Computer Science. Actually, I haven't taken AP Computer Science, so maybe one of the TAs can answer that.
I think it is similar to AP Computer Science Principles, so it's like another one that's there.
Question was, if I've taken Math 54, should I still take 16A? Almost always the answer is yes. Under some circumstances, there are other pathways for students who have already taken a class like linear algebra and Math 54. But that reminds me of actually, let me pull up this frequently asked questions just so that I think that these questions are coming up. So let me just bring this up. So 3 quick questions, right? So should I take 16A my first semester at Cal? The answer is almost certainly yes, if you've taken an AP Calculus class. 16A and 61A are designed to go together. We make sure, for example, that the midterms don't clash and things like that. So it's a good idea to sign up for these classes at the same time. Should I take 16A and 16B before I take CS70? Again, the answer is yes. You should take 16A and 16B before you take CS70. They're designed to help you do better in 70. So I recommend that. And do I need to take a linear algebra class before I take 16A? The answer is absolutely not. We will teach you from the ground up everything you need to know about linear algebra. So there's no need for you to start with taking a linear algebra class first. We're intending for this class to be taken by first semester freshmen. Will the class be hard? Yes, but every single class that you take your first semester is probably going to be hard. In fact, it should be hard, because if it was easy, then it wouldn't be challenging yourself by going to college. It would be the same as your previous institution. So your first year here, things will be challenging, and that'll be good. But there's no need for you to take a linear algebra class before taking this class. Any last questions? Math 53 is not required. Yeah, Math 53 is agree, correct. Math 53 is not required for 16A. If you take 16A, does that mean you still have to take a linear algebra course? The answer is no. You do not have to take a linear algebra course. 16A and 16B together will fulfill your linear algebra requirement. For people who are wondering about the summer offering of 16A, the summer offering of 16A and 16B will happen. This will, there will be a remote online version of the labs that you can take. And if you're interested in taking this, whether you're transferring to Berkeley or are just interested in learning the material, or whether you're going to be a freshman, this is an option that you should definitely consider. I know I won't be teaching it, but I will be involved in the course, and I know that the instructors who are teaching it are absolutely fantastic. So I think that I would definitely recommend taking it over the summer. I don't see any disadvantages to doing that other than not being able to have a summer break, because it will be an intense course. So the offering over the summer is much more compressed. Instead of spreading it out over summer, you learn everything in 1 month. So those are the pros and cons to think about from that perspective. Do you recommend taking 16A or 61A for summer if I have a programming background from high school? Absolutely. 16A and 61A, welcome people from all different backgrounds. 61A and 16A both will be a little bit easier if you have some programming background. Students sometimes decide to take Data 8 or CS10 before they take either of these, because those are a little bit easier courses, and then they take 61A and 16A their following semester. But if you have some programming background, absolutely you should take 16A and 61A, though I should emphasize that that is not required. You can take both of these classes, with very little programming background as well. Okay, so we're about at time. I'm going to stop the recording. I'm happy to stick around for a couple more questions if people are interested. But I wanted to, thank everyone for coming to our virtual Cal Day presentation. And I think, it's a challenging time for everyone. It's a challenging time for educators. It's a challenging time for students. It's a challenging time for families. And it's a challenging time for every single person in our community. And we're trying to do everything we can from our perspective on the faculty to make sure that our students are supported and their educational experience is not diminished through this crisis. And while this crisis is going to leave us with some challenges and some things will not ever be the same, we're going to do our best to have a positive and encouraging learning environment for every single one of you who will be here in the fall. So I really look forward to seeing as many of you as possible. I'm happy to stick around for a little bit longer to take questions. And most importantly, while you're making these decisions on where to go to college and what to major in and all of these other things, remember to celebrate yourself and congratulate yourself. A lot of you got into Berkeley, got in somewhere else, and that is amazing. You deserve a massive big hand. if we were in the big auditorium, I would make everyone stand up and clap for themselves, because too often we don't celebrate ourselves enough. So make sure that you remember that you're completely amazing. No matter what choices you make, everything's gonna be okay. So hang in there and good luck.